This question is about orbits and space. It says the diagram shows 4 planets, P, Q, R and S, orbiting around a star. Part A says that this combination of planets and a star is most like a galaxy, the Milky Way, the solar system and the universe. Now remember that we're on planet Earth, which is a planet orbiting our star, which is the sun. We've got a moon orbiting us, and our sun, along with all the planets and all the moons that orbit the planets, is called our solar system. Now, there are many millions of solar systems just within our galaxy that we call the Milky Way. And then there are many millions and billions of galaxies within what we know as the universe. And so the universe is the biggest thing that we currently have any understanding of, and then it's made up of many galaxies. Our galaxy is the Milky Way, and in it has many, many, many solar systems, such as our own. Now, a solar system is a star that is orbited by planets. So this is most like the solar system. Part B says that planet Q, this planet here, has a moon. And it asks us to draw the orbit of this moon. Now, moons follow pretty much circular orbits, and they're going to be quite small. You know, if you drew an orbit which went out into the orbital path of one of the other planets, I think the examiner's going to take a mark off you for that, because that moon is not going to exist for very long. It's going to crash into one of the other planets, or even be stolen by the other planet and become a moon of that planet. So make sure that your circle is nearly a circle and not an ellipse, and that it's quite small. Part C says that on the diagram, draw the orbit of a comet. Now, a comet, unlike moons and planets, has a very elliptical orbit. And the sun is the centre of the orbit, but it's not really the centre in the same way as we would say that this planet Q is the centre of the moon's orbit. It's that the comet orbits around the star, but then it moves much, much further out. If you were to draw it like this, then you wouldn't get the second mark. You'd only get the first mark for drawing an ellipse. So you've got to make sure that the sun is at one end of the ellipse, and then the orbit continues right out to the furthest edges of the solar system. Part D says that planets nearer the sun or star take less time to orbit the star, and then it asks us to suggest why. Well, if a planet has a smaller orbital radius, then the actual orbital path is going to be much, much smaller. And also, the closer a planet is to a star, the stronger the force of gravity, and therefore the larger the speed will be for the planet. So we can say two things for this. One is that they follow a smaller orbital path, and that's enough for our 1 mark. And we could also say that they also travel at a higher speed. Part 2. Planet P makes 1 complete orbit. During this time, Planet R makes more orbits than S, Planet R makes fewer orbits than Q, Planet S makes more orbits than P, and Planet Q makes fewer orbits than P. So Planet P is the furthest out. It's going to have the longest orbital period or time to go all the way around. So R makes more orbits than S. No, that's not going to be true because S is closer. It's going to make more orbits than R. Planet R makes fewer orbits than Q. Again, no. Q is further out, so R is going to make more orbits than Q. Planet S makes more orbits than P. Yep. Planet S is definitely going to make more orbits than P because it's got a lot less far to travel and it's going to be moving faster. And then let's just double check. Planet Q, this one here, makes fewer orbits than Planet P. Again, no, it's closer. It's going to be following a smaller orbit at a higher speed. It's going to be making more orbits. So that's definitely wrong as well. So the answer is C. E, as the planets orbit the star, the distances between the planets change, and that's because they're not all orbiting at the same speed, so there's going to be some overlapping happening, and sometimes they're going to be next to each other, sometimes they're going to be on the other side of the star. It says planet P is 200 million kilometres from the star, so if I draw in that, we've got 200 million kilometres. And then planet R is 50 million kilometres. So this is planet R. And if I draw that in, that's 50 million kilometres from the star. Then it asks us to calculate the maximum distance between planet P and R. So the maximum distance is going to be when P is here and R is here. So then we're going to have 200 plus 50 million. So 200 plus 50 is 250 million kilometres. Make sure that the examiner hasn't just left it as kilometres, and then we'd have to add in the million. Then it asks us to calculate the minimum distance between planet P and planet R. Now the minimum distance is going to be when perhaps P is still here, but R is here. Now this time we've got this section here being 50 million and this whole section is 200 million. So this time we've got to do 200 minus 50. So the minimum distance is going to be 150 million kilometres.